All right, you're on.
Okay, right. Platform.
Platform stuff. So, we're up to, again, finding just progress being very, very slow. Um, the other thing was the trucking guys. Like, I've been stalled for so long on this platform piece that I'm delayed on getting their frame or their modifications, and it's sort of compounding. And I really need to shift that one off my plate, but I also need to get this platform up, and it's just feeling like the walls are closing in type of thing. I'm like, rah, we just need
Yeah,
this bit.
man. Yeah,
Um,
I know what you're saying. I've been there. Spinning plates, and they're all starting to wobble.
yeah, I know. Okay, so where I got to was I got this, the back end of the chats is what I got started. And when I say started, I would say that that's probably 90% of the thing, because as it turns out, running independent, untrusted code, most of the world is against you. Browsers do it quite well, I think, because everything from the browser's point of view is untrusted. And so, inside one trusted realm, having another untrusted realm sandboxed is a relatively small step. But
Yeah, yeah,
all of the other conventional software tools assume that you own the whole server, and
that
they
makes
don't.
sense. You go from trusted to untrusted is a big thing. Going from untrusted to untrusted is a small thing.
Yeah, untrusted. You've suffered already, so you're like
Yeah.
you're mostly there. It's just cosmetics. But if you are trusted and you're like, I'd like to run something untrusted, and it's like, wait a minute, buddy, wait a
Yeah.
minute. So even though Dino was a great gift to us, where it preserved the browser's isolation mechanisms and provided access to them for the developers, it has still been a large number of hurdles to try to get untrusted server side code to run on Deno in an effective way. The latest hurdle I hit was the fact that it will not, if you compile the Deno program, it will not run dynamically imported modules. So to run the dynamically imported modules, I have to have a live mutable running version of Deno, and then I can do um, imports of dynamic code. But the catch is I have to do some gymnastics to make sure I don't get stuck on whatever version it loaded first, because it caches it and doesn't give you a way to cleanse the cache. So if you publish your NAP and update it during the lifetime of the server will continue to serve the old one, and there's no way off it without some tricks. So
Well, that sounds gnarly.
there's a lot of things against us to run untrusted code server side, but I believe that that is part of the offering that we make. So we navigate those ugly bits so that other people don't have to. And what I present here is a front end frame that is untrusted, served from a different origin, yada yada, and it is executing on the back end fully untrusted, not untrusted, fully independent code that was dynamically loaded at runtime so that I can publish to JSR or NPM, and then this system will run it. And so the code is modular. It is dynamically loaded on the fly, rather than having to have an everything program where you compile the kitchen sink in. You can now load these modular bits on the fly. And so this shows that functionality happening in its rudimentary state. So, without further ado, the very not very glamorous button of new chat. You click the button, the wheel spins, and then eventually, hopefully,
What's happening in the background? Right, that wheel spinning there.
a new chat is being made, and you should see it pop up here. There we go.
And there's a new repo to represent that, or is that inside of a repo? Or?
This is represented by, if I pick the home repo, and in the home repo I pick the main branch, and I look in the files, there's a folder called chats, and in
Right.
here,
there it is. Yeah,
in
3,
here,
4. Is that?
yeah, I'll pull it up in a separate tab so you can see it. So here's all the different things. So we got 4J7R down there, and then over here we got 4J7R down there. So you go in there,
Nice. Okay.
and you get, ta-da, a config.json, which will extend out to have various things like what are the current settings for this chat,
Right.
all that stuff. And then there will be a folder in here called messages, and in there will be one file per message, and probably one folder per participant as well. So I'll segment the messages by the participants. But my point is that that is all that labor was to be able to run this external module. This module right here is the chats NAP, and it is in charge of managing this folder. It's installed to manage the chats folder. So there was also a bunch of other awkward sort of rules I've had to make up on the fly, like how can I make a NAP be in charge of a folder? What if I want the same NAP to be in charge of 2 different folders? How do I send an action to each one? You know, all these kinds of kind of difficult things, right? Or things like, you know, what does it mean to, so you'll notice that this chat changed. See, we're at like K7Q3 up there, but if I click over here, well, it's supposed to change, but it didn't. My bad. Oh, sorry. I need to click the resume button. There we go. So, that also didn't work. Whatever. Demos. But the point is, you click here, it changes the chat over here, and so what the complication with that is that the state board is a collection of isolated frames. The chat, I could make it as a frame, but the point is that I needed to invent or make our own version of intents, because if I just, first of all, there's the selection, right? So I can do selections, and I can have those selections be updated so that you can use them in transcludes. So the way that handles it is that the frame API exposes a callback called onSelection, uninventively. Whenever the selection changes, the frame can call that callback, and then whatever the parent of that frame is understands that within that frame, something, but the selection changed, and then it knows what to do with it. If I want to select something and then change the rendering of another frame, I need to say something different. It can't be selection. It needs to be, I want to do something. And so I want to do something this is one of the great powers that ChatGPT, particularly O3 with web browsing, brought, is that this problem is common to all major operating systems. And so I can ask O3 Show me how it's done in Linux, Mac OS, Windows, Android, iPhone. And I can look at all those strategies and be like, oh, yep, I think I see the winner here. And then really all I'm doing is allowing a set of, or predefining a set of standard actions that the framework knows about. So like one of the standard actions is view. So view means here's the path to a file, which is a repo, a branch, a file path, and possibly a commit, or if I omit it, I mean the latest thing. And then the intent view is to say, look at the file and figure out how to show it as best you know how. Then there's also intents like action, like edit, where you're like, here's a file, I want to edit it. I made the intent chats, again, unimaginatively, because to pass the folder of a chat along with the intent of set active chat means to say I'm trying to set the active chat to be this thing. And so the hosting page can decide to ignore those cues or not, or it knows how to do something special with them, which allows us to separate out things like selecting a chat from resuming a chat, where I want to make the chat show up here.
Right. Yeah.
Right.
Yeah.
So that was an unexpected complication, but that's common to all operating systems, that problem. It's almost like the associated with, like when you associate a program with a file extension or some way to configure your system to take certain actions, standard actions.
Yes. Yeah.
Yeah, but so that I took a stab at that. It sort of works. I'll just leave it at the skeleton thing. But here's basically the this is the JavaScript package published on JSR that is being run by the back end of this.
Mm-hmm.
And so this is where it does things like creates the new chat, deletes the chat. So I can go delete, and then the whirly button spins, and then ta-da, the whole chat disappeared. I hope you didn't want that. And then the next piece I was going to hook up was infer, which is to say, hey, I want to call this AI model. That's what's going to make the next message. And so...
No, I didn't follow that.
Well, at the moment, the background chat nap is responsible for deleting or cleaning up each chat folder and also for making a new one. But when I'm over here and I type a message, it is also the nap that will receive that message and will generate the AI call and then create the new file within the folder. So the new file inside of the messages folder here, and that's how the AI comes into the system.
Right. So the model is defined in config, and is when you're on the left-hand side, the model that you're actually using refers to config, saying what should I call?
Yeah, and other things like temperature, any pre-configured tools and things like that. And I was gonna make that little cog show.
Oh, that's got some side benefits. Because quite often the selection of the model depends on what you're trying to do.
Yeah.
And so if you tie that to a config on the chat when you're going back, you don't have to do that. Flip to the model and so on. Can you change the config halfway through a chat?
Yeah. So I was gonna make it that when you click this cog, you'll get like a friendly UI representation of the JSON data that's in the config file, and you can modify it there.
Okay, that's cool.
Yeah, but it needs to be, it's going to be more than just that, because you might want to switch. It might not be a model that you want. You might want to run a NAP instead, and the NAP might
Yeah,
make, say, parallel model calls, or it might do some more advanced things. And so it's really a ground, a base simple structure that we can extend with more advanced ways of interacting with AIs.
sure. And also, you could have, now this is in the future, but a nap calling a nap might want to boost the model into the model it thinks this other, you know, thread or chat should be considered by. It's like,
Yep, yep. But that would show up as a tool call within the calling chat.
mm-hmm.
Um, if you are thinking about an agent style call where it would be a call off to an independent entity, then that agent would be reconfiguring its config based on what it thought it needed to do to best answer the question.
Yeah, yeah. And it's
Um,
that parsimonious approach I think is going to be quite important because
the configurable approach, yeah, the pluggable,
yeah,
configurable, and then
well the
also browsable if you as you need.
also it's not just a matter of which model is the cheapest tokens. Each model has it's almost like a personality that is starting to emerge.
Mm,
You
yeah,
know,
yeah.
O3,
Traits. It
4,
has straight
and Gemini
traits.
have different responses, and so that sounds like something a NAT could get its teeth into and saying,
Yeah.
you're asking for a qualitative assessment of this, and actually now you're asking for just straight, you know, academic or statistical response, and so let's switch it to that.
Hmm.
But yeah, that's medium term. Been
Yeah.
doing a
So
bit of research on that one, but it's good.
it's still not exactly clear to me how we will achieve all of the advanced functionality we want, but I have a feeling it can be done by adapting this chat model, which is like messages will go in a folder, config goes in JSON, other types of things like naps that this chat can talk to can go there, summarizations, and I don't know exactly how, but I feel like we can patch or incrementally add in all the extra features like triggers, like background summarization, the building of memory. I'm pretty sure those things can be fitted or can be fat into this arrangement. I just don't know exactly how.
Yeah, I agree. It just feels like there's a solution there, isn't it?
Yeah, yeah. It feels like there's a solution. So I was just shooting for the minimum one, and then I'll take a look. But it's just taking so long. I'm like, man, like it's because I
Well,
keep hitting all these little things, right? Like I'm like, oh, now dynamic code doesn't load on the server. Well, great. Here we go. Let's solve that one, right? And then it's it's just such painful games.
I wouldn't worry too much about it because painful gains means high barrier to entry. So again, back to what we're doing. Is it this the right thing? Yes, I think it is. Still,
It
um,
seems very apparent that the entire computing world is against running lightweight, untrusted code, the same as what a browser has been doing since donkey's years.
that's the
It's
point. And the point
yeah,
is, in a distributed world where you've just got self-selecting agents or people turning up and doing stuff, it has to be untrusted.
yeah. It should be
Um,
untrusted anyway. I mean,
and the only way you can get it trusted is to centralize, audit, blah blah blah, all that
well,
heavy
that's the thing. Like,
lifting
as soon
industry
as you
stuff.
pull in one dependency, one package into your code, you can no longer really, strictly speaking, call it trusted. Because,
Yeah,
like, first of all, are you going to check it every time there's a patch? Or do you just want the patch to fix your bug? You know, but I realized something deeper about that relationship with packages, code, and trust. We have made this modular system where each module is untrusted, and they can be coordinated together to do something, but they are treated as untrusted. Now, that's actually quite a subtle difference to how a typical app runs. A typical app, you're not recommended to do this, but the vast majority of devs do it, is that you take all your dependencies and you bundle them together in one big blob, and then you serve it out to your unsuspecting customers or victims, depending on how honest you want to be about your relationship.
With potentially quite a large number of attack vectors. Yeah.
Like a huge surface, right? And then, but really, what this model gives us is that you can vend an app where your dependencies are treated as untrusted by the substrate. And so your area of trust responsibility stays at the code that you made, and your dependencies are run in sandboxes, which you're supposed to do as a dev, and you can do it with a lot of work, but nobody does because it's a massive pain in the tits.
It's very synonymous with virtualized apps.
Where each app runs as a VM, you mean?
Yeah.
Yeah. It's exactly that, but lighter, much lighter.
Yeah, and now even VMs have. There were a few attack vectors a few years ago where a VM running on the same machine could actually influence another VM, but these were really kind of, national level NSA kind of hacks. Hard to do. Whereas it's really quite easy to get an attack vector if you just say, "I'm importing everything.
Yeah,
I trust it all."
Yeah, and that's a real bad position.
Yeah.
So it is coming together. It is definitely feasible. It is, as you can see, working in a demonstration level environment. The Git-based model appears to be still holding up, so that's an interesting win. I realized that I could take the sharding concept and I could modularize that so that you would be free to supply or choose different sharding strategies based on your need. So I just picked one because my need was easy to program, fast enough to handle 30,000 customers. That won't work so well for 2 billion records, but there are other data structures. Like, what I realized is that all of these fancy data structures like tries, different kinds of hash tables, all these kinds of ways of sharding can be perfectly represented in a Git file system.
Well, yeah, I mean, the Git file system almost becomes the presentation layer of whichever sharding strategy you want to employ.
Yeah, and the interface to provide a standard interface to create a new sharding strategy is remarkably simple. It's physical to logical, so like, here's a physical path, convert it back to the logical path so that it basically undoes the sharding. And the other is the reverse, which is, here's a logical path, turn it into the sharded path, the physical path, so we can store it on disk. And once you got that, you can kind of do all these kinds of fancy data structures, which is quite relieving or fulfilling, I suppose. And so we're not stuck with just a handful of, or at the moment, just one hard-coded sharding structure. It's like, well, these can be selected based on your needs, based on the properties of these different sharding algorithms or strategies.
Yeah, and if you want to, home brew one of them, because you want, data sovereignty, then fine.
Well, data sovereignty would be available to all of those sharding methods. The types of features you would get different from one to the other are performance under different kinds of load, like many small files, um,
Yes,
large
yes, yes.
numbers
Yeah,
of
yeah, yeah.
files.
Really, yeah, really what I was pointing at is you can, there's no barriers to whatever you choose to do on-prem, because there's the presentation layer of
Oh,
Git.
you're meaning like you could get very high performance on-prem
Yeah,
operations because you can pick a sharding strategy to suit whatever
yeah.
characteristics you need.
And the layer above doesn't care.
Yeah. Yep. 100%. So yeah, the Git model still standing. I think that's the one I'm most, I wouldn't say nervous about. It's the one I'm most eager to prove all the way to the end, because not because I'm worried about Git, but because I know from my past 14 odd iterations that the data structure is the killer. Like the data structure is the reason why we had to switch. If I look back at why we failed in all those previous iterations, it was pretty much always, apart from the political problems that occurred at the time, which the technical problems were related to the data layer performance and the data layer complexity. So trying to get an extra feature in there and then you see it start ballooning in complexity, the Git model's holding. It's holding well.
Yes. Well, it's a slightly different point, but it's worth reiterating again. The Git presentation allowing rollbacks and audits is actually commercially really valuable.
Okay, that's good. That's good.
I'm getting a lot of questions, which I'm thinking, well, the Git model solves that.
Right.
Whereas previously, it's like, well, let's get the digital tapes out of Iron Mountain. Oh, they're sticky. You know, fucking hell. Well, this one's failed.
Yeah.
4 days to get it back. That's really powerful.
Okay, great. Great. I think it's also good that it's familiar, so it's compatible. You know, like going in and out of GitHub are things that people understand. I strongly like the fact that I can browse my data structure. I can browse it directly in a file system, or I can browse it with like a nap that makes it look fancy and gives me buttons and all that. But under the hood, I know it's files and I can see them, and I may be able to manipulate them if they aren't locked and controlled by a nap. I like that transparency. The fact that I can back this whole thing up to GitHub and move it or run it somewhere else or roll it back, that's a win from my point of view.
No, I agree. And being able to roll back, I was slightly disconcerted on the move to mobile phones, where they seemed, well, certainly on iOS, to remove the file structure behind it. So I do things on my iPhone, don't know where it's going.
Right.
Can't do anything other than what the app provides, which is not great. And you know, Apple's way of dealing with that is, hey, send us your app, and we'll charge you 30% of your income to say whether it's okay. And it's like, well, where's my fucking data?
Yeah.
Including things I found out a wee while back, which involved me taking some steps to stop this. Things like internet connections from a keyboard. There was a keyboard installed,
Yeah.
and I was looking at the traffic, and it's like, why does a keyboard need an internet connection? It's like, what are you doing?
What you doing?
Which at the consumer level was probably whatever. But at the levels we're looking at, you know, like War Fabric and so on, is like a big no-no.
Yeah, you can't be anything but explicit and deliberate about what you're communicating with. And I think that's
Right.
another feature of this modular system, is that we can run an app in a guaranteed closed box, and we can guarantee that data never left the system, because that's the base level of, that's how apps run. They
Right.
get nothing.
Yeah. Yeah. And again, it's in that untrusted. Weirdly, now one of the things I'll talk about when I come onto my segment is around War Fabric. But War Fabric is looking increasingly like, if you take Ukraine, disputed effort, but there's no time to audit each of these, 2, 3 guy in the garage efforts, but you still want to bring them together quickly. But I'll go into why I'm saying that. But all of this supports that.
Right. Yeah, so I mean that's where we're at. I'm pained and embarrassed by how slow it is, but as I explained, it's been against the grain of general computing. And so speed comes when you're just, running with the river.
Yeah,
But
yeah, sure.
this is crossing.
This is not script kiddie stuff. Right?
Nah, but it does work, I think, is what I gotta sort of cling on to. My slipping fingers here is that it does actually work, and the benefit of being able to upgrade just a component without touching the certification membrane of the rest of the app is really quite good, because when you upgrade everything at once, is it still audited? No, it's now a different app, and you need to start again. But
here's a somewhat blast from the past. A formal proof of security given our friend in Paris.
yeah,
How would it stand up to that, or how?
I think it would stand up
End.
pretty good. At the moment, it's able to lean on other systems. Like, it can say its guarantees are as strong as Deno, for example, or its guarantees are as strong as the iframe sandbox in a browser. And so
it inherits the guarantees.
Yeah, it inherits guarantees from big targets, like big, powerful targets, and because even Deno leans on the Chrome engine. It's like Deno inherits its sandbox ability from Chrome with a few extra bits added. So it's not the
Right.
majority of the code. It's their weakness is how they implemented their hooks into it. But they too are, reasonably big enough to.
Right. So the formal guarantees would be around black boxing audits of whether any particular Lego brick is.
Yeah. Like you can, like, did we use the Lego brick correctly? Yes or no?
Yeah.
Separately, how secure is that Lego brick? Well, it does matter, but it's also not our problem alone. Like, that's the whole internet's problem too. And then, is the bespoke stuff that we made safe and doesn't make the right design choices in all other areas? Can you get escalation of privilege, remote code execution, all those kinds of things? And then the last layer would be, have we got defense in depth, where if the Deno sandbox was breached, how do we have a backstop for that not breaching our infrastructure as well? And so,
well, that part seems to be the I'll say the weakest, but I think the architecture is pretty strong. But if the file structure itself was breached, then you still have the hashes. If someone wants to change something.
like, there's still, there's levels of degradation, some of which you wouldn't have to suffer, right? Like, denial of access is not really as much a thing in a content address distributed system as it is in a mutable centralized database where
Well,
it's like
exactly.
if
Distribution is all about integrity of the data.
yeah, like if it's
It's not
hashes all
about
the way down.
accessibility. And confidentiality is another matter. So you got your CIA, um, but integrity of the data. You know that the data that you're dealing with is absolute. Um,
Yeah,
I believe in this one. Whether it's confidential, then that's a different attack vector.
that's different. Yeah,
You know, whether you can actually get it if there's a DDoS, that's kind of yeah, okay, fine. That's the brute force kind of attack vector. It's very difficult to deal with that because there's always ways of just swamping the thing. But data integrity and accessibility are far more important.
right.
Sorry, data integrity and confidentiality are important. Accessibility is less important.
Okay. Well, yeah, I think we got a good model there. I'm still nervous about being able to have it run in consensus, but I'm sure that it can without much tinkering because it's really just agreeing on a git commit and then making some
Well, yeah.
optimizations for the
I
sake of
mean,
speed.
surely that's a solved problem. What you're doing is
Um,
agreeing on a batch of
yeah,
data which you can hash.
in theory it is, but the issue is in practice, is it still responsive enough and cheap enough computationally to be
Ah,
useful? And
yeah,
does
okay,
it
yeah.
waste data? Like, does it generate huge amounts of excess data that you still have to keep around? And it's all those kinds of things that are hard to know ahead of time. They feel solvable, but I would love to get it going because there's there's two major problems with consensus for us.
Mhm.
The first is I think we need to make some um, modifications to or some relaxations around how Git commits work to allow multiple parties to race ahead but be forgiving. Like if say you had 10 nodes, for whatever reason they were split 5 and 5 for a time, and then this group of 5 only worked on the path in folder A, and this group over here only worked on the path in folder B. When they go to merge again, you shouldn't have to throw all that out and build it up
Yeah.
again, because it's like,
Yeah, I
well,
see what you're saying.
you
I
know,
see what you're saying.
there
It's
weren't
like it doesn't
conflicts.
matter,
Yeah,
just guys
yeah,
agree.
there are elements of it doesn't matter, and I also stumbled upon what I think is a way to summarize the key issue I have with the way that with decentralization is very centralized right now in the likes of Ethereum and Bitcoin. It's that
It's
the
ironic, isn't it? Single chain thing.
yeah, the parties that are interested in the data are the only ones that need to reach consensus on it. We don't need the whole world to reach consensus on a chat that you and I are having. You and I need to reach consensus on it.
Well, it's kind of a permission thing. So if we never have a permission, you never be asked. Then why are
Yeah,
you
like
worried about consensus?
it's almost like permissions is also a key to massive scalability, because you just keep your clusters of permission data and you coordinate only when you need to. That's why many chains, I believe,
Well,
is
yeah, I was
is a
about to
good
say,
model.
like blast from the past. I mean, that's multi-chain, right?
That's
Um,
multi-chain, yeah, and then each chain can coordinate with another one just a little bit, so like they can send messages and back and forth. And so transclusion is like the next generation of chain joining, because that's what it was made for.
well,
Was
yeah, and depending on what you care about, having consensus is an event, and then you could bump it up one layer and saying, well, can we have consensus? That consensus is reached. Um, so it is hierarchical, um,
yeah,
and you kind of want to keep it as low as possible. It's like, what you don't want is a bunch of people agreeing. You don't want the entire world to agree because the
no,
entire world is never going to get access to that information anyway.
that's
And they're
right. And
never going
even
to
even if
ask.
they did, even if it was public, it's if the whole world could read, it's still rare that you'd need the whole world to write. Like, I still can't think of any reason why the whole world should
That's a
write
fair
to a
point.
particular piece on the file system.
Right.
So you can keep these groups small, and then repos give us a natural sort of domain packaging, an organization method where it's like, this is the repo of the English version of the technology section of Wikipedia.
Yeah.
That's all. You don't need to have these big, like, all the data in the world in this one data structure. It's like, no,
Yeah.
I don't want that.
Yeah. Yeah. I agree. And that hierarchical thing is maybe you want to bump it up to a larger group to say, was this, if we
Yeah.
count consensus as an audit, was this consensus reached properly?
Yep.
And you can have a consensus about whether it was or not. And then, depending on how important it is, maybe, you could go up to the entire world if we ever vote in a world president.
Yeah.
Everyone agree that the votes were done, but they don't ever need to go into the detail because it's modularized. You go down to states, you go down to counties, whatever. Go down to villages if you want.
Yeah.
But it's the consensus is multi-chain.
Yeah, and so the second problem with consensus that we have is making the clever design of a, not necessarily a currency, but an asset tracking system where it can act like a bar of gold, where, like, you can take the bar of gold and you can hide it so that only you have it, but when you pop it out again, you can verify that it is gold. You can pass it to someone else and not have the whole world see it, and then they can pop up somewhere else and they're like, oh, this last time we saw this, it belonged to Tom. Now you've popped up and it belongs to you. That's fine. The world doesn't need to know all its journey in between, so long as it's the correct bar last time we saw it and it's the correct bar when it came back. It's no one's business what happened in between, and that's a consensus issue.
Can you give me two twice? Thanks. Would it make sense that each repo has its own token?
I don't think so, but that's me assuming I know what you mean by token. Each repo has its own consensus, it has its own data ledger, and to generate any kind of token would be simply to store data of some kind in that repo. And so you could argue it has its own token. Its data is its token.
Right. And what the reason I was asking that is gold is a form of centralized idea of everyone knows what gold's worth. But if you are working in one repo and you produce value and say we store NFTs inside of that repo, the question comes, how do you transfer value now?
Well, that wasn't at all what I meant. I think that's a political and psychological question, not a technical question. The
Okay.
technical question part is the allowing data integrity to be witnessed and then have the data integrity disappear, come back, and be verified as valid again, whilst having it done unknown things in the meantime. Like,
Yes, and oh, you say it's a political thing. And it's more social, I guess. But if you generate value, say in the Dreamcatcher nap,
yep,
and then you want to transfer that out. Now, what happens on the nap stays on the nap,
yeah,
but you know that there's not been any, in terms of the the outward surface, or you're trusting that inside the NAP is dealing in the same rules that the NAP that's asking. So if you generated value inside of a repo, let's say an innovation, and you've generated value in there and you've got an NFT in there, so then how do you transfer up?
Well, it depends on the recipient, and you have to accept the value as being the same or transferable. I was more meaning the tracking of external assets, like tracking, say, Ethereum. Like if an Ethereum token.
Oh yeah, I see what you're saying. Yeah. Okay, sorry to cut you off there. Yeah, we are talking about different things.
Okay.
I'll come back to this, but there is a
All right.
very interesting emergent property of having repos as trusted black boxes,
Right.
and then in terms of consensus, you can say yes, this repo reached consensus, and then you can have a number of layers above that saying we all agree that this repo says it reached consensus without knowing anything about that consensus. That
Right.
feels like a way of tracking value through that. So if you wanted to transfer value, it's like you generated value in this repo, you want to transfer over to buy stuff in this other repo in the Dreamcatcher way. We just need to know that consensus
Yeah,
was reached.
I don't know if that is going to be solid enough without being complicated or needing some sort of high power third party involved. But additionally, the tracking of a ledger should be external to both those repos. So you shouldn't really be able to generate value inside a repo. The value needs to be outside of the repo. Otherwise, it makes it very awkward to move it around. And that's kind
Mm-hmm.
of why we need to make a currency, because it should be an external system that tracks all that, but it's designed in such a way that you can take some of that value, hide it, move it around privately, and then bring it back. And
That's yeah. I
but
agree.
but I think, yeah, generating value inside a repo and then recognizing it across the wider network is not a problem. Uh, it's I I'm not sure we need to solve that, but I'm happy to talk through it with you when the time comes about it.
It's a long term thing, but it
Yeah.
seems on first blush possible because we've got consensus, or we don't have consensus, but if we do have consensus, we can have consensus around repos, we can have consensus around meta repos, or groups of repos, and then we can advertise that, yeah, we are happy with this, and we will. It's a little bit like, when you see uh, paper money, it says a promise to pay. Now, what does that promise mean? In this situation, the promise means that the repo that issues that promise is algorithmically on the hooks for someone calling that promise in. Which sounds
Yeah, that's perfectly fine. But those types of arrangements are less valuable than a like the value of money is based upon its widespread acceptance. And so if you've run your own mint and an individual repo's minted it, its acceptance is naturally going to be stunted compared to a system that was set up purposefully to be globally exchangeable.
I wonder. We'll come back to this. This is definitely a
Sure,
long-term thing.
sure.
Um,
Okay, so
just for the recording, so I remember what I'm thinking about this point. It seems like if you have this isolation around individual consensus blocks, then that block should be able to issue a promissory note that would be one-to-one exchangeable, so long as the thing you're exchanging with is content that your internal consensus is going to actually pay out on a grounding event, say, dollars coming in. It's like, okay, so I now want to pull dollars in because someone else is cashing out. So long as that chain of trust is infallible, or in quotes, then you should be able to allow each black box to agree who owns what, or who is owed what, who has what balance, and interchange with other blocks that trust that other box, and that is down to consensus between those two blocks. That was mostly for my notes. We don't need to discuss because this is long term.
All right. So where are we at? So this is the state of the platform. I don't know how consensus is going to go. I really am nervous about doing it. I want to do it as soon as possible because it proves out, like, I don't know what features we need beyond consensus. Like, if we can do that, then we're like, okay, we have got the prototype complete. We can now thicken the structure because we know that it doesn't fall off a cliff. That's my deep concern, is like, do we have enough motivation, resources, patience, and will the world wait long enough for us to get to consensus? Because that is the final stage. That's the end state. Like, we are done, and it's just
my current view is we don't need consensus yet. Isolation is huge.
Secure isolation, right?
Yeah, if we look at the demand that's coming
and
through,
multi-host. Multi-host seems important because that. Excuse me.
Oh, hello. That was quite dramatic.
That is
You just got snot all over your headset now.
I didn't, but thank you for the image. Multi-host is important to be able to jump between on-prem and other areas of on-prem.
Yes.
So between departments.
That I'm getting a lot. Not necessarily within an organization. The perimeter seems to be
in or out
on
right?
the organization. And they want to be able to audit it, and they want to be able to pull it on-prem or offload. Take your ISO 27001 and give it to AWS to deal with.
Yeah, or hybrid, where they're living in between.
Right. Right.
So my personal goal, it doesn't yet have a clear monetary backing, so it'll just have to wait, is to be able to eke out every little spare piece of compute resource across the whole org all the time, and then that's your server. And each individual PC is coordinating using consensus to marshal resources around the place, and that's your on-prem cluster.
Yeah.
And that's like War Fabric is basically saying, well, the battlefield data center should be on the battlefield. And, maybe a tank has more compute than a rifle, but still, it's all running the same fabric.
Right.
And so I guess just to touch on a weak concept that I'm struggling to paint strongly, in War Fabric, I would expect that you would end up with a bunch of independent units of people and machines that were feeding information in to these AI models that were distributed at the edge and asking things like, what should I do next? And even though each AI model is cut off from all the others momentarily at any given moment in the fog of war, the fact that each model would give a consistent answer based on what it knew means that these units can stay in coordination even though they are completely in the dark. They would all they'd know what the last snapshot of comms was. They'd run probabilities that it's wrong or it's an error or how much progress another platoon's made. And they'd all know that every other unit is trying to currently figure out what they're doing as well. And so the emergent behavior you could start to see is this behavior that's controlled by AIs that are working for the good of the organism. And so you can start to see where in civilian life you could have individuals that were all following the instructions of their personal agent because they knew that the personal agent was looking for the overall good of the organism, and they didn't need to be talking to everyone all the time. They just needed to be following the programming, the knowledge base, right?
This is one of the this is one of one of the topics I was going to talk about, because there is a very early days deployed example of that in Ukraine right now. I got a briefing about it, but it's open source, so can't talk about it.
Right.
Is there anything else you want to go through before I go into that?
Is this still enough? What I'm doing?
Will
you see it hitting?
More work?
Well, I'm like, this is all we got. Is that going to be enough? That's sort of what I'm getting at.
It is. I'll go back to, I want a pony for Christmas, which is this persistent memory, being able to pull in context and apply naps and have naps talk to naps. You do that, you can do a shit ton of stuff.
Okay. I still don't know exactly how Stux is gonna work. I guess
I think, given the description of the kind of minimum thing, I think we could work through innovations using just those building blocks.
Right. I guess I'm a little discouraged by the amount of time and detail that it's taken just to get the basic chat thing even half working. And it's made me gun shy for how much work remains for these other items that we don't have clear eyes on exactly how to do it. But to counterbalance that, all of the hard work of getting the chats thing has been silent under the hood infrastructure stuff. Once the infrastructure problems have a tendency to go away, like as they get solved, they don't just keep replicating forever. Those problems decrease in number, frequency, the number of sharp edges and sort of things to bang your elbow on in the dark go down as each one is solved, and as more movement, as more motion occurs through the platform. As we do more capabilities, we knock off more rough edges each time, so that counterbalances that. But I'm just calling out the fact that rate of change of chats has been abysmally slow. It could be that rate of change of innovations is abysmally slow. I know that once innovations gets going, that's when the pace picks up. I'm calling out that there may be a longer dead zone in between now and operating Stux than what we there's more uncertainty in my head about how long that'll take at the moment.
I think I'm more bullish on this than you are.
Is that like a classic project management versus the dev, bro? You're like, oh, come on.
Yeah.
Oh, go on.
It's like, oh, it's easy. The reason is, once we've got the building blocks to put stuff together, then we can cut and splice innovations many ways. And then we're in a thought space that doesn't have to worry about the substrate.
Yeah, that's true. Yeah, right now it's all substrate and it's pain. but
I think
soon
this is
that
going to be as
goes.
painful as going to be. Now,
Yeah, it's a good point.
honing innovations to the point where it's palpable and, obviously the thing for others to use, I think will be painful, but it'll be in a different headspace.
Different layer, eh? And it'll be a
Yeah.
shared layer. Like you'll be suffering too, and I'll just
Right. Yeah.
get to laugh,
Exactly.
I guess. The
Yeah.
other area, processes. So long running processes doesn't seem that hard now because I'm doing processes in a way to make these, to make the new chat and to delete the old one. So processes is sort of working. It's just not the high scale um, burstable elastic thing yet. So that's another area of work. I don't worry too much about that because I'm like, we
Yeah.
can
Would,
we can survive a
yeah.
long way without that. That's
Yeah.
really key for managing long horizon jobs and key for um, repeatability, which is essential for consensus. So repeatability of the NAP invocations requires this process management layer to be there. But if
Yeah.
we don't need consensus now, then we can forego this process manager for the meantime.
I agree. I'll stick that in the medium bucket.
Okay. Okay. And then no, I think you're good at that point. It's grinding, dude. I don't know. I don't know what to do about it. I'm sorry to sound like a pussy, but it is grinding. I'm like, dude,
No, I get it.
it's
And I think we'll look back on this period where you, well, in many respects, you had to stand alone because there's only so much I can give encouragement, I can give feedback, and I can give hints and tips, and well, not even tips.
yeah. I
But
suppose this is what I signed up for, right? This is the dead zone where it's like
yeah,
across the desert. Here's here's some
well,
random stuff.
this is Britain in 1940. It's like anyone else? Anyone else can help? We're getting
Yeah,
fucking
right.
bombed.
I know. Yeah. So anyway, all right. I'll fucking suck it up and keep on slugging. But
Right,
things that
cool.
things are tough. I don't know what another alternative is, and we must complete this. I'm just
Yeah,
warning. It's tough, and it's still taking time. So
that's, I see you. I see you. I know. Um, I just wish I could help more. But when we get onto the likes of innovation,
yeah, and CRM
then
tracking, like leads
yeah,
management, making bots, running evals, all that, then it starts to
yeah,
get really exciting, I think.
yeah. Right. Can I have just a 1 minute break?
Sure.
I need to go and I've got barking outside. I don't know
Okay.
why.
Uh-oh.
Don't want the dogs escaping.
Oh dear. Okay.
Be
I'll
right
see you
back.
soon. Yep.
Okay, back.
All right.
Yeah, all good. Right. War Fabric. Um,
I got a couple more things
yeah,
to
go for it.
go that I just need to get into your head,
Hmm.
to make sure that we're seeing the same future unfold. All right, so I'll leave all this. So far, so good. There's no objections or errors that you can see. I'll keep slugging along and get the chats up, and then the transcludes, and then we'll do some tuning and fucking around, and then that's as good as we can do, right?
Yeah,
And
yeah.
the trucking guys, I feel like they're unfortunately going to have to wait until we get this bit up, because this is starting to feel like the fulcrum. Like, if we don't have this, we're dead in the water. If we delay this, we're in trouble. And so it's like, I don't see any advantage in doing their work now before this. They've
I
had a
agree.
huge chunk of time. Um, so yeah, I'll just head down. It's gonna cost a lot of brownie points, but if we don't do it, I think we're dead. So
Yeah, yeah, I
we got
agree.
to do it. Um, the thing I wanted to cover with you was the cursor changelog.
Okay.
There has begun to be features that sound a lot like what we're talking about. Here is an example where you can keep um, the bot is making a to-do list and working its way
Okay.
through it.
Mm-hmm.
And that's important because we were talking about this kind of thing, and here it is.
Yeah, that's not fundamental to us, though. That's not our, because it's the idea of having a
Nah,
bot to plan. Um,
yeah, I guess the positive side of this is that we come up with these advanced features that we talk about because we think we need them to achieve capacity in the Dreamcatcher or solve hard
mhm.
problems in the Dreamcatcher. And so the more these guys go first, the more we can just learn from that and pull it in and have it be a familiar interface to people so that we can then start to deploy it.
Well, that's precisely the point. We talked about this before. We don't want to be spending any effort on a problem that seems to have an obvious solution because we can wait for someone else to
Yeah,
solve
I
that.
know, I know the logic. I just can't help but feeling like we come up with these schemes and these models and these things, and then we're early, and then they arrive, and it didn't arrive from us, and it bothers me that we're not the
I've had,
ones pushing
yeah,
those out. You
I
know?
know, I know exactly what you're saying, and I've seen a couple of things of saying, "Oh, I said that," or
Yeah,
"We said that."
yeah,
It's
I
like,
know.
and these guys have done it. But
It's
back
like
to
we're
the Citadel.
sacrificing.
Yeah, but the Citadel, which were bought, I still have not seen anyone look at the distribution and optimization of innovation. Nobody is looking
No
at it.
one's even close, eh? Okay,
No.
and the other tool that they added here is the ability to queue messages. So see how they're typing while the bot's thinking, and it's just queuing up instructions.
Okay,
And
that's
that
good.
was something we'd spoken about in the
Yeah.
last call. And then I'd assume eventually you'll be able to edit them or put conditionals in there, or it'll have it display like a simple flowchart and all that.
Yeah.
Memories is now popping up. We know that we need memories, and memories is like a background thread that kind of interprets whatever the human says and then updates rules on the fly so that the human never has to repeat themselves.
Hmm.
But that seems to be a table stakes feature now. Um, yeah, that was.
It's
Oh,
The Slacker?
this part. Using agents in Slack, right? Because we still didn't, even though we sort of went over this interface, we still haven't got to the point where we can actually do an agent and then play with an agent. And so that's sort of, that to me is the next major, that's the milestone. If we can do agents on this platform, then I'll be like, oh, phew, I think we might be getting somewhere.
Yeah, but it's more than agents in Slack. It's like your boss in Slack, isn't it? Where
Agents in control as opposed to
Yeah.
just, yeah. So what they've shown here is that you can hook up the Cursor platform to Slack and then chat with it, and it goes off and does stuff and comes back. So it's sort of, I guess, in our system, we would have it so that you were having chats, group chats with your contacts, and then someone asks a bot to go do something, and then the agent runs off and does it and comes back, except it's for more than code. Like, I think what we're seeing is we're seeing coding lead the way in terms of the ergonomics and the interaction methods of controlling agents to do hard tasks, but where we really want to hit is how to get agents to do all the other tasks in the world and use those same innovations and tools like chats, long running agents, queued tasks, mini workflows, memories. And it's really about how to get a bot to do real world tasks like emailing, contacting, maybe some code, bookkeeping, rule setting, research, going off and doing things before it gets told, those types of things. That's where we want to get to.
Yeah.
So yeah, I just thought it was innovative that Cursor shifted to this method or to this mode, and I found it interesting that now the Cursor agent can actually read the Slack thread, and it ingests the Slack thread as part of its context before answering the question, which is pretty fun.
It is, but oh my god, I still hate Slack.
Yeah, I know.
The signal to noise ratio in Slack is horrendous.
I know. And that's where we're making the chats, and then the chats will start to become intelligent because they'll get compressed and squished and made smart.
Yeah. And I really don't care that it's your poodle's birthday or that you had pizza last night.
No one cares. Okay, that's me, buddy. Over to you.
All right. So, I was going to talk about War Fabric and possibly the first glimmerings that it's emerging anyway. So this is a briefing. I don't have anything to show and tell. Well, I've got to tell, but I don't have show. There has been over the last week the surfacing of a project that's been going on for the last 2 years around how do you detect drones, how do you detect incoming threats in Ukraine without radar. Now, radar is great at high-level threats, and their range is unbeaten, and the coordination is unbeaten in terms of applying some force against incoming threats, but it's very expensive. But a lot of the Shaheeds and other long-range drones, I don't know if you've been following the figures, but the hit rate of Ukraine taking down Shaheeds is averaging around about 89%.
Okay.
Which is bloody high.
It's still not where it needs to be.
It's still not 100%, but 89%. Now, part of this, I was digging into, ask a few questions, and Ukrainians released information about this project. So it's around acoustic triangulation of noise patterns.
Oh, okay. Like a massive sensor array, like what we spoke about for the Citizens OS, and it's
Precisely.
like spread across the whole city, and then it's like listening for the sound of this drone.
Precisely. Yeah, and
Right.
it's gone through a few phases. Originally, they had um, series hardware in a small number of locations, and what it would do is what you'd expect. They trained it on training data to recognize the noise of a drone, or any kind of quadcopter or anything like that,
Yeah.
and differentiate it from a bee buzzing right next to the sensor.
Right. Yeah. Right. Warning.
Um,
Release them all. Oh, wait.
exactly.
Wait. Not the honey.
Right. So that's the first phase. The second phase is they networked it, uh, and uh, that was okay, but the units were quite still expensive. But now this is the interesting thing for Dreamcatcher. A couple guys decided, hey, couldn't you just like hook up a cell phone and like a small mic, uh, and that cell phone's probably got enough, just enough to at the edge say this is interesting, and
Right.
then send it back
Right.
something more essentially
Yeah.
to say, is this interesting? But
Right.
also, it knows its location,
Yeah.
and then can triangulate. Now they've got 10,000 of these units out, and they are parabolic dishes with off the shelf microphone
Right.
and a cell phone,
Epic.
lanked on the back, $500 a piece.
Epic.
And they're doing what radar can't do, which is detect um, low level attacks.
Yeah, because it's under the radar, but
Right.
because it's under the radar, now it's in sound range.
Yeah. Yeah.
That's
Now the
epic.
interesting the reason this has popped to the surface is the head of NATO went on, because this information was released and so on, and the head of NATO was asked about it, and he said this is crazy mad, because they managed to develop this without any centralized needs analysis. We want a system to
Yeah.
do this.
Yeah.
They had systems from different groups.
It
Some of
was
them
like
well funded. Some of them a
decentralized
couple of
nerds,
guys.
basically.
Yeah, decentralized nerds. They said, "Well, how about you do this?" And they ended up with a system. I think they've got 10,000 nodes now.
Right.
Those 10,000 nodes cost about 50 million in total from start to finish. The entire program.
Which is dirt cheap in comparison to the Iron Dome.
Well, it's about the cost of 2 Patriot missiles, and they're expendable, right? And they've got almost complete coverage on this. But also the interesting thing is it's meshed at the edge. So
Oh, that would have taken some software.
yeah, well, I don't know how they did it, but that's what they're saying.
Right.
They're basically going, the unit, this parabolic dish with a phone at the back end, is saying, "Oh, I've heard of something interesting. Anyone else know anything interesting about this?" And it's like, "Oh, yeah, I've heard about it." The
Yeah.
range is not that great. The range is about 8 kilometers. But because these things are so dirt cheap, and you can just basically screw them to a tree,
Yeah.
tell it its location. Well, it knows its location,
Yeah.
and then it meshes up, and they've kind of solved the low-level attack problem.
Right. That's
So
awesome.
yeah, but the interesting thing is they've solved the low-level attack problem in a noisy environment, but they've solved it without any kind of procurement project, without
Right.
anyone saying they needed to solve this.
Right. Because it turns out that off the shelf components can
Yeah,
defeat.
yeah. It's basically microphone, 3D printed dish, and a mobile phone
Right.
and software, and that's it.
Right. Right.
Um, and now they've got an ability that NATO are looking at, going, "What the hell, we want that," because
Right.
nap of Earth flying is still impossible for radar to do anything about.
Yeah.
and even if it gives false positives, and
Yeah,
I was
the
hearing that
fact that
false
it gives
positives.
some positive positives is sort of what you.
Yeah, exactly. And I think the the hit rate on accuracy is around about 90%, so not
That's
perfect.
epic. That's epic for what it
But
it
that
is.
allows the more expensive units to say, "Oh, something's happening here. Let's
Yeah,
look at it." Um, so I thought that was very interesting. Not because of the well, yes, because of the edge manufacture of something that not only had not been thought about, but simply, the 100 million, 400 million uh, radar stations can't do, but it was done by a kind of bunch of dudes just going, hey. Now, the first wave of it, the acoustic thing was interesting because it was a German company that was using AI to generate voice of celebrities for Hollywood.
right,
And their first iteration was really way too expensive. Those are the guys that put out like 40 stations
right.
as a test of concept, and it's like, it's kind of working. Yeah, okay. Their hit rate was really quite low. But these guys picked up and ran with the idea, um, and managed to get the unit cost so low that you get a lot of noisy data back, but from a lot of nodes at the edge. The edge does some pre-processing, and the pre-processing is actually quite hard to do, but as it turns out, you can do it with an Android phone.
Right.
And then send back, hey, I think something's in,
Yeah,
I
like
think
a
I hear
wake
something.
word. Yeah, like
Yeah,
it might be something. Someone else take a look. Yeah,
right.
that's really cool.
Yeah, it doesn't even have directional information, but because there's so many of them, you can get directional information because you know the location. Um, so the reason I'm saying this is an example of War Fabric because it doesn't matter if someone spots one of these dishes and pulls it down, steals the iPhone. Does
Yeah.
not matter for the network.
No, no, it doesn't. That's fascinating. That's who we want to be. Like we want to be the
Yeah,
operating system underneath that. We want to be the innovation hub where those kinds of ideas can be ideated and
yeah,
coordinated and random, have a crack at it and then see some light. No procurement process. Bunch of nerds, iterative, homegrown tech, dirt cheap,
right.
taking on
But
the big
the
problems.
the reason the head of NATO was saying this is crazy mad is flash to bang was 2 years.
Right. Even that should be
Um,
a lot
that's to
faster.
deployment in a war zone. two
Yeah. It
years.
should
It's
it
like,
should have been about 3 months.
well, yeah. And in usual procurement ways, it would probably be about 15 years.
It would never have happened.
Yeah.
I think
So,
that also speaks to the incentives as well. Like procurement needs big paydays, and that's not $500 dishes. So
right. Yeah,
there's
yeah, exactly. And overheads, and they need big paydays because they've got
right.
a lot of people
So
looking at it.
if we could mechanize that process, then it should be like a 3 month thing. You have a bright idea, and then in 3 months' time, it's out there being used, and the AIs are helping boost the good ideas and being like, this is feasible, this is practical. We need some tests done. Here's the outstanding jobs to be done. You can do this in your backyard. Ideas.
Right, right.
Because
And
that
and
the,
again,
the
the second,
uh, you go.
the the very interesting thing to me was that head of NATO, whose budget is in the tens of billions, um, was looking at a bunch of like guys, just hobbling stuff together and producing a capability that not only had not thought about, but even if they had thought about it, would be years away. and the incentive for those guys is they're under attack. I mean,
Yeah.
it's like two dudes in a garage in Ukraine going, well, that's a good idea, but they're doing it all wrong. It's way too expensive. And let's just get some 3D printed dishes and order some microphones, stick a Android in the back, mesh it. Yeah, sure, that's not easy to do. It took them a couple of years, but they did it in such a remarkably fast turnaround. Now, the thing is, now it's known it's going to be spoofed, right? Oh, and the other thing is, they're now launching,
Gliders.
instead of tying it to trees, they're doing acoustic sensors on drones.
Yeah. So you drag a net.
mesh.
Yeah, yeah.
So now
A sensor net.
you're extending your range, and you just have a bunch of loitering drones up there
Yeah.
listening.
Yeah.
And now you're moving into the kind of radar kind of situation.
Radar-esque. Yeah, yeah.
Yeah. And it's like, it's still really cheap.
It's still cheap.
Now, what I was about to say is, the next thing that's going to happen is there are going to be countermeasures, of course.
Yeah.
So if you have something based on sound, you could stick up a drone with a loudspeaker.
Yeah, okay, so the battle starts to become flash to bang and cost, right? Because, like, let's assume for argument's sake that there is no way to win technologically if the other side, because the other side has a brain and has physics and has money, right?
Yeah.
So the only way to win at this game is if, like, it does seem like there's almost a natural advantage in some ways to defending versus attacking for some types of operation, and the other, it's like attacking versus defending if you can have surprise. So canceling all those things out, what I'm trying to get at is that, okay, you go microphones on trees, great. Now we get gliders. Then you have microphones on drones. Now you get like ultra stealth gliders, or you get noisy gliders where they pop a countermeasure that's just loud. And then,
or helium balloons that can carry a bigger payload and
like a
loiter.
Right, like a Zeppelin that just comes over.
Right, and does on-prem computation.
Yeah, but the battle is won if the cost to develop the reply is more than the cost to develop the counter reply each time.
That's precisely the point. Precisely the point.
And so, like, it's probably expensive to develop a silent drone, given that you're already committed to a particular model of drone, you're tooled up, you got that working, and now how fast can you now make it soundless?
Right, or sound like a flock of birds.
Yeah, versus...
Or even be agile in how it sounds, maybe.
Yeah. And so...
transmits noise in the right frequency to sound like wind.
Yeah, so the upgrade time and the upgrade cost is really, at the end of the day, the number of moves that determine your war machine. Like, how many moves can you make and in what time? And can the other guy outdo you for cheaper? Like, it's a game of cheapness, right? And software is king of cheap upgrades. Like, if you just roll out a new AI model and now it can hear better, that's massively winning.
Yeah, precisely so. But it's also interesting that the guys that are really getting freaked out are the guys with the 20-30 billion budget. They're getting freaked out because they're having to make decisions about something that'll be deployed maybe in 10 years' time.
Yeah.
3 months.
So there's probably a massive opportunity for us to pitch a mechanized version of that OODA loop, and we're like, here's a funnel, you put the money in, and you get the innovation out.
Yeah.
And if you don't get the innovation, then you still have your 24 billion just sitting there because you only pay for the innovation.
Yeah. And also on the stuck loop thing, stating what your problem is without stating what the solution you need is to make it happen, I think is really important. You say, we can't detect low-level drones. Maybe there's other ways. Who knows? Um, but putting the problem out without stating the solution, I think, is where the military complex is going wrong, because they put out very detailed specs on what
Yeah,
it's required to do.
yeah, and it's not pure enough. The problem.
Yeah, yeah. And also, its benefit to us. I think this gives us perhaps our first real world hard example of where distributed innovation
Right.
can
It's
have
right. Its
pace.
utility is plain. So we're saying let's mechanize it. Let's boost the coordination and network with AI, and let's also chuck some NATO money in there.
Yeah,
Right.
yeah,
That's the model that we're saying is better.
yeah. And it would just need even, tiny little drop of NATO's budget
Yeah.
is what these guys got.
Yeah.
Um,
Right. And then that means that if we can deploy that using NATO money and we show permissions and secrecy and all that as required,
oh, I'm
that's
not sure even secrecy is a problem.
well, yeah, but I mean, it should be there if you want it,
Um,
basically.
Here's a straw man counter argument. Um,
That's
if
cool.
you,
I don't want to argue with you about
all
it.
right,
It
okay,
can be there
all
or it
right,
cannot be there. Um,
yeah,
the
yeah,
the point is that sounds like, whilst that's a very grandiose thing to try and pick, it seems obvious that that's what's required for NATO: mechanized, distributed innovation, so that they can pop out things like that in a methodical way.
yes, yes, and in a way that the design, build, operate, and learn cycle is measured in months.
Days.
Yeah,
Days. Like it should be running a simulator by the time you get up the next day.
yeah. And the interesting thing about this example, as far as I can see, there were four groups from an AI company all the way down to two dudes that made this happen. But they didn't have contracts.
Ah,
They just kind of did it because
hmm.
yeah, war will worry out
Yeah,
about IP later.
yeah, because war.
Yeah.
Hmm.
So
That's fascinating.
there's I mean what we're talking about war fabric is exactly this is distributing
So
to
that
the edge.
yeah, so the angle that we would need to go down to get taken seriously is to deliver a couple of innovations that actually mean something, like through Tifu or whatever, and then go knock on some key doors and be like, look, here's the case studies of this thing working. Here's how long we estimate that piece of distributed innovation would have taken without this coordination mechanism. And so that's why we need this funding for these stucks
Right.
to get that more secure and more repeatable, more reliable, and you know,
Right, right. Because I mean, this innovation, which is proving value, real value right now, kind of grew randomly because of a whole bunch of people deciding independently to, all right, okay, I could improve that. I'm just going to improve it.
yeah. But that's the same problem as how do you build a sewage system on an island that you're trying to make habitable? Like it's all the same stuff for peace and for war.
It is. It is. And one of the benefits, I think, this I won't not even call it a program because there wasn't a program. It was just eclectic and just grew up like weeds. You didn't ask
Yeah.
them to be there, but
Nah.
hey, um, the interesting thing was each group got access to what the other group was doing,
Right.
which is
Right.
why I think one of the reasons I think. military spending is so high is because they insist on it being secret.
Absolutely. And now, how do you know that that's the best answer if you can't tell anyone? You know?
Right, right. And so the OODA loop cycle on secrecy is really long. It's like I generate a Patriot missile, and probably
Yeah,
someone somewhere is trying to generate a counter Patriot,
yeah. It's
system.
basically the future of military spending, and I don't know what happens when both sides start spending like this, but it should be good because I think it favors openness. It favors wholesome motives. It doesn't seem to favor dark motives that well, I think, just because
Well,
it encourages free thought, I suppose.
exactly. And in a war zone, you have the benefit of being able to recover the hardware of the other side occasionally. And you just have to
Well,
look at
you've
the
got that in peacetime as well, right? Like,
well, yeah, yeah. But if you count that as basically open source, because you can see what the other
yeah,
guy
yeah,
is doing.
it's available source, source available.
Available source, yeah. And if you look at what's happening, even over the last 6 months, so at the start of the year, as you know, we're doing a lot of stuff on fiber optic drones.
Yeah,
Um, those are falling out of favor
right.
um, in favor of
Autonomous drones.
autonomous AI-driven drones, where
Right. Yeah, right.
you train it.
Right.
So, and that was a 6 month cycle.
Yeah.
The fiber optic drones were a response to jamming of RF. RF was, the jamming of the RF was a response to RF drones, POV.
Mm.
And so you've got a cycle here which is measured in months.
Mm.
Now, if I'd argue, if a country less illustrious than Ukraine would have just simply be thinking we need more tanks, we need more missiles, we need more jets, and sure, they need those. Those have the place, but
Yeah.
actually, the cycle, the really interesting cycle, is in this distributed bunch of, as we were talking about 6 years ago. Ukrainians are very highly educated, very motivated, and
Yeah.
hard as nails.
Yeah.
Um,
But
and
there's something else there though. Like those big pieces of hardware, you know, like 30 million bucks for a Sukhoi. You can't, like, if the whole acoustic defense network was 50 million bucks, right? You're sort of like, you can't just keep plowing Sukhois into, like, the
exactly,
money ratio. No one's got infinite money. And
yeah,
a $30 million anything is a bad investment now. It's like, that's not good. You could have done smarter.
exactly so. And when there's other programs which are open source, we can speak um, about kind of garage shop built sonobuoys that fuck with submarines. And so the thing with the submarine is, I think I've talked about this before. If there are certain acoustic signatures, they duck and go deep because
Yeah.
they think they've got a frigate on their ass.
Oh, and so they were able to sound like a frigate, but not be a frigate.
Right, right. And these are, literally, I think maybe $10,000 a piece.
Man, if you could pop a submarine, that would
Yeah.
be like such a bad deal for like, oh dear, like, who sunk the submarine? And I think they would tend to go down with a bang, right? Like, they don't go down a little bit, like,
No, yeah.
like,
Well, absolutely. Well, these sonobuoys were about disrupting operations. So if
right,
you suspected a submarine was operating in this area, stick out 100 of these things, and the
right.
submarine goes away because it can't actually do
Take the
anything.
risk. Yeah, because
Yeah,
it's there's a gamble or a calculus that's like the big piece of hardware has to run away from the little drone
right.
because it might just die, and it's like,
Yeah,
oh, that would be really bad.
if you're carrying a Ming vase, over a hard floor, you don't want a whole bunch of toddlers with remote control cars
Right.
around you.
That's right. Or someone with some marbles that they just roll out.
Yeah, yeah. You just get out of there,
Yeah.
and effectively that is neutralized. That unit
Area
is not
denial.
necessarily destroyed;
Right.
it's just neutralized. Can't do
Right.
anything.
Right. It sort of
But it's too
stalemates
precious.
you because you're like,
Yeah, it's too precious. That's
Man, there's
that's
some
the downside.
fascinating developments. I just don't know what happens when both sides use innovation networks, but we'll have to see because that's really where it's going.
Yeah. Well, who knows where it goes? But that's the whole point of innovation. The
Yeah,
fact is, the person who can innovate 1% faster than the other one will win.
that's right. And so I think I like to imagine it also becomes a numbers game. Like if you assume that at big enough numbers the innovation rate is evenly distributed amongst people,
Hmm.
then who can innovate faster is a headcount issue,
Yeah.
right?
Yeah.
And
Yeah.
so
It's
you
the
could
number
have
of
a
people on the
weird
network.
form
Yeah.
of democracy because the war is won by how much support is on your side, and everyone's voting with their innovation. They're voting with their intellect, their time, their money, and that's how the votes get cast to say we want things to go this way, not that way.
Yeah. Yeah. Precisely. And in retrospect, I mean, this is not new. One thing in the Second World War that Allies did quite well was come up with cunning plans, which on the face of it sounded ludicrous. Things like inflatable tanks,
Right.
where they and loudspeakers to make the noises right, where they thought the Nazis thought there's an entire division
Right.
where there wasn't.
There's a funny thing about dictatorship and innovation. Like, they don't go well together, those things.
No, no, they really don't. Um, and I could go into why that is, but we don't need to study that too hard to just see centralized is a few brains thinking about it, whereas decentralized is a lot of brains thinking about it.
But it's not just, it's a lot of brains with the freedom to explore and to play and to
Yeah.
test. So, yeah, look, I mean, that is epic. Like, it's just so frustrating that for us to meet that demand, I need this fucking thing to work. And I'm like, what?
Well, I'll take some comfort in that. I think uh, war, and by war, I mean any kind of urgent need. It could be an
Existential.
earthquake. Yeah, it could be humanitarian needs. It could be funding or whatever. Any kind of need that can be met in a distributed way is this. And I think things have fundamentally changed. I don't think they're going to
It's
go
never
back.
going back. It's never, ever going back.
Yeah,
And in fact,
even
it's going to get worse. Like, there's going to be AI dogs and AI foot soldiers
right.
walking around, and it's just going to be AI all the way. And it comes down to innovation, countermeasures, countermeasures, counter, blah, 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 manufacturing speed, deployment speed, logistics solutions. Like,
Exactly.
that's a big problem space. It's like, well, we got all this stuff. It needs to be somewhere else. How?
Oh, logistics is perfect. And there's and I didn't mention it, but you just remind me. Ukrainians again have put in place Amazon-style logistics. So they've got supplies in warehouses, and units can go into an app and say, "I need this, this, this," and then they've got the distribution network, and it turns up.
So it's like
Hugely, hugely more
Amazon
efficient.
Warfighter or Amazon
Yeah,
Prime Frontline.
exactly. Hugely more efficient because otherwise, what you're doing is you're turning up with like a 4-ton truck
Mm,
with a whole bunch of stuff that they might not need. And
right.
it's like, we got plenty of those. And they were a bit shit.
Right.
But also with the Amazon model, what they're doing is, well, maybe we don't need to manufacture as many of those things because
I guess
nobody's
yeah,
asking for
my
them.
view of what the perfect city under siege looks like is starting to get clearer. Like if there were a bunch of delivery drones that also carried with them the sensor networks to detect incoming stuff, and they could actually do ramming attacks to shield against incoming missiles and things. And now your logistics is taken care of. You've always got this fleet in the air. The cost is lowered because now you're also, you're supplementing it with this work that it does. You're increasing quality of life. You've now got this, instead of 10,000, you might have 100,000 because this economic venture is booming. And now you're like at peace, enjoying a higher quality of life than all the rest of us who don't have a drone delivery network overhead all the time. And you're safer. And it's like making you money instead of costing. Like that starts to sound like the future.
It does, doesn't it?
And then
And the
also,
thing,
like, you'd also want the city to spread out. Like, you want to disperse the cities thinly so that they're deeply, rapidly connected by these drone networks, which also provide umbrella cover. But even if you did get a drone through, the loss of assets and life is reduced by the dispersal ratio with no
well,
loss of convenience.
that is a very interesting point because I don't know if you've seen this pattern. Um, Ukraine have established an ability to hit with precision targets up to about 1,200 kilometers inside of Russia,
Right,
and they are going after the factories that build Shaheeds or
right,
the factories that chemical factories that build explosives.
right, right.
Every day, um, I'm seeing on the news wires that there are precision strikes against logistics, and it is seriously degrading the ability. You can see it in the stats. Interesting enough, you can see it in the number of waves and even in the number of dead on the Russian
Ah,
side.
like their logistical strikes are having a great toll on the Shaheed rate.
And the quid pro quo is why is Russia not doing that to Ukraine? The reason is um, you've got a whole dispersed bunch of guys who are like maybe 2 to 8 guys in a small workshop
Yeah.
producing drones.
Oh,
I mean,
because their
would you
workforce
hit?
is more distributed than Russia's. Like Russia's
Yeah,
is central, big factory.
yeah. I mean, would you hit? Do you go after this garage or that garage?
Right.
Yeah. And even if you manage to get a precision strike on it, the value that you've eroded for Ukraine's effort, is it worth the cost of that drone?
That's right. Is
Probably
it
not.
worth the cost of the drone?
Yeah.
Because I understood that's how a lot of the Japanese manufacturing plants for cars work. They had these central factories, but it was actually the surrounding workshops that did all these odd jobs and made batches of parts, that was really where the core manufacturing happened. And so it was really a broadly distributed manufacturing system.
Yeah. Yeah. And I think that is it's being slightly degraded because of tariffs. But if you even look at Apple, the Apple device, it says designed in California because that's about all they did in California. Everything
Hmm.
else was in China, India, Thailand, Vietnam, constructed, in a third-party country is all over the place
Right.
because that was the best thing to do. Now, what that means is you got, well, take Teslas for example. You know where the mega factories are,
Right.
and if you were at war, you could take out a mega factory.
That's
Yeah,
right.
sure.
Easy. You take it out
But
easy.
taking out a distributed supply chain, it's like a bit more tricky.
Right.
And
A
if you go
smaller
to a
factory, I think.
micro supply chain cycle.
Yeah, and it's easier. It's a more software or reconfigurable, like because they get adaptive tools like 3D printers, like robot welding arms that can be reprogrammed. And so, as the innovation cycle uh, repeats or iterates,
Well,
the reprogrammable factory is better poised.
well, the 3D printing thing is another excellent point because someone somewhere comes up with a better wing design for a Shahid.
Yeah,
Send out the file,
yeah,
then anyone with a 3D printer in this distributed network is now working on the
yeah,
latest improvement.
yeah.
It's very difficult to deal with that. Um, it's almost like guerrilla warfare for logistics.
Organized like guerrilla warfare.
Yeah.
Yeah, man, we got to get there. Do you think we can go from this thing to that thing that we just described? Because
Yes, I do. Because
why? Why do you think
um,
that?
because it's been built up to be distributed. It's been built up for the sharing of ideas and the sharing of incentives, especially when we
Yep.
get innovation
Yeah. That's
there.
very true. Actually, that's very true.
And now, even okay, so this is a bit down the road. It can even push into the physical world about someone's got a 3D printer and someone says, "Oh, I need this part 3D printed," and so even the manufacturing can be distributed. I need this boat to go over this river.
Yeah, I
Um,
guess I've sort of. It's hard to see that. I know what you mean.
it's easy in a war because the incentives are clear. The trick, I think, will be to convert that to when there's not a war and the incentives go down to, well, why should I?
There's always a war.
There is always a war. Um, or there's always a zone of conflict. And we've got two or three of those on our chip
But you're
in the
right.
cupboard.
The substrate we have is designed to be distributed, and you can't say that about much else. And so, as clunky as it is, its native operating environment is distributed.
And I think we'll benefit from the one-eyed, man in the kingdom of the blind thing.
The one-eyed drone. Yeah.
Because at the moment, there is no method other than people just doing it under their own incentive.
Yeah, there's no mechanized coordination. There's no AI boosted coordination. There's no social network with AI in it.
Yeah,
It's terribly frustrating, actually.
yeah. And that social network piece is networks are all about nodes and connections, of course, but the connections are the interesting thing because that's where you can share. Hey, we've got this changed wing design for this drone. Hey guys, there it is. Incentivizing someone to put their own work out to a network in a war is easy enough. Doing that outside of a war, I think, will come down to recognition and attribution.
Right,
But
attribution, yeah, it needs to make good money, fair money, fast money.
Yeah,
Right.
but in any instance where the incentive isn't necessarily even recognition,
Yeah.
yet alone monetary compensation, then if there is an earthquake in Mexico City, for example, and you've got a whole bunch of guys with capabilities and a whole bunch of guys with needs, this will just flare off as a way of coordinating.
Yeah, that's right. That's right. Okay. I got some other stuff to talk to you about off record. Do you have any other on record stuff to go over?
I got one thing, but I can
Yep.
do it quite briefly.
Okay.
Which is I'm getting and this is interesting. I'd love your view on this one. I'm getting a lot of interest around the use of this sort of system for OSINT,
Yep.
which I wasn't expecting, but it kind of makes sense.
This would be perfect for that. How to start and where to start are probably the.
Well, I've got currently 2 in the hopper saying what we really want is OSINT. The interesting thing is they want their OSINT to be closed, but I think I can work on
Closed open source in intelligence.
we got 2 organizations both using OSINT, and it's like, why do you guys not share information?
Right. Well, I think there's big money to be made in brokering sharing between those orgs, where each one has an agent that communicates with the other one's agent to sort of jostle around and figure out what would be good to trade on and what wouldn't, and what would be good to cooperate on, and then they can do little flash joint ventures, like for a moment we were like, we want to know this, oh, we do too, bang, half the price, twice the result, and then they pull apart again, and they just rapidly come together for only that narrow purpose.
That's an interesting thing. So, for example, you are one company specializing in OSINT. I'm another company in OSINT. I've spent money, and you've spent money on gathering, our network of information. And we think it would be good to trade, but you can't tell me your secrets, and I can't tell you your secrets.
Yeah.
In order to define the value.
Right.
So we need some way of arbitration between
them. Yeah. And so the AIs would broker these sort of mini projects. Yeah. Because otherwise the overhead of negotiating the project is too heavy for humans. But the AIs could go at it rapidly, and then, if a human had to just do the final sign off, it's like, oh, that makes sense, we're keen. That makes sense, we're keen. Oh, hell no, not that. And then now you've got like very effective cross-party communication, no broker required in the middle, just AI.
Yeah, and the interesting thing with OSINT is all the information is open source by definition, but the effort to collate it is potentially closed source. But the other party
extracting the meaning is like that's private.
Exactly,
because it gives away your intentions as well. Like what you're focusing on is private. You need to.
Yeah, but that could be, sharded up,
throw a few smoke bombs in there, some like fake things, or like, oh, I'm trying to find out about porcupines. What do you guys know?
Exactly, but there seems to be a thing there as well. But that's early days on that one.
That's a fun one.
We'll come back on that one.
Yeah.
Right.
All right. Oh, very good.
Yeah.